The box who are included all parts who are necessary for the FluDi. At first you can see the receiver for with the X and Y position detector, the supply power unit, so-called echo pack. Next one shows us the transmitter with a distance measurement system and the laser, adjustable laser for X and Y measurement. Then we need two parts of Bluetooth, two receivers, two transmitters, the magnetic clamper, the remote control, two supply power units for charging the receiver and transmitter, laser and electronics, several cables and also a CD for the software. That's enough for the complete FluDi system to measure XY deviation of an axis up to 40 meters and also distances absolute at the same time. First step is to place the receiver, for instance, coarsely on the carrier of this axis. Here we want to measure the deviation in Y and the deviation in X together with distances from a 0 point. This we have to place with helping by a magnetic clamper and an iron bar the transmitter, the laser transmitter, the laser transmitter is fixed with a standard clamper from the laser interferometer on the magnetic clamper. Direction shows to the receiver, nearly to the receiver. Combine the receiver with the Bluetooth transmitter. It's simple to do. You connect it here and also put the connector USB to the echo pack and start the echo pack. That's enough what you have to do on the side of the transmitter. Is combined with a USB cable, connected with a USB cable to the PC. The second Bluetooth station is also placed on a USB in a free port of the PC. This PC allows us to bring the total energy to the transmitter, to the two lasers for measurement. You don't need any echo pack and so on. We start the software to adjust the system. You can see the red dot from the distance laser. It comes out of the upper area and the lower area is switched on the second laser for measuring straightness. How to adjust? You bring the lower dot into the area of the receiver. I will do that. This is normally enough for adjustment. For the fine adjustment, you can see here a red ball. So you bring it in the, before starting the measurement, in the nearly the center of the cross. With helping of these two adjustment screws, you can bring the laser in a fine alignment direct to the target, and it is also shown in the software with a red ball. You must draw it in the center line. Now if you have adjusted the system completely, you can see the upper red dot for the distance measurement and the lower red dot for the XY deviation. The red ball shows us the XY deviation of the adjustment. It's not critical for the measurement itself.
Distance.
The software is started under a special name, and here you can see three values. The first value is the absolute distance of the carrier, of the machine, of the distance of the receiver. The other both values show us the deviation in X and in Y. The deviation now you can see in millimeters of the red ball is not important for the measurement itself, because we are correct mathematically this millimeter deviation from the value of straightness in X and in Y. It gives us also a help for long distances to bring the beam on the receiver target. This is important, not the absolute value of the target itself.
Okay.
Now this system has been well adjusted. We can start a measurement with helping for triggering with the remote control. Starting the measurement, before starting we set the system to 0. We start the measurement, set it, this total system to 0 with this button, and go to start measurement. With this remote control you can go to the axis and say first measurement point with trigger will be calculated. The second one may be in a distance of about 50 millimeters. Second measurement point. Third, and so on, and so on. The same you are doing backward. That's all. Then you go to the PC or PDA or notebook. When you have finished the measurement, stop the measurement, load it into the measurement file, and so you have three values: the distances of the carrier, of the receiver, absolute measured and also the deviation in X and in Y for the position where you have triggered. This is for straight and measurement you have to do. It's simple to handle and the accuracy is nearly a half micron for X and Y and distances up to 15 meters, and so you can get good results.
Gut.